Hi, I'm Connor.
My name's Charles.
We're doing this project for ENM2104 Instrumentation and Measurement.
And we built an audio spectrum analyzer using Arduino.
This is our audio spectrum analyzer. It's utilizing Arduino circuitry, which is then performing all the calculations and passing to the OLED screen. And on the OLED screen, we're getting the frequency from low frequency to high frequency. It's about 40 hertz to 4 kilohertz, and the Y is displaying the amplitude of those given frequencies.
So the audio input comes in from our microphone, which is then passed onto our multi-stage switch to select our filters. It then passes through either our low pass, high pass, or band pass filters back into the Arduino for processing, and then output onto the LED, OLED. So this is our audio spectrum with no filters. As we progress from low frequencies up to high within our frequency range. You can see it moved across the screen as it transitioned from low to high.
Here we're declaring our libraries. We've got SPI for your standard Arduino. The Adafruit libraries are there for the OLED screen. Wire is so we can process the SDA and SCL clock line for the OLED. And again, the fixFFT.h. That is for the fast Fourier transform processing. So scrolling down, we define the OLED reset, we declare the OLED display, we create some characters so that we can process information into a set of arrays, and we're doing 256 for each, XY values, and setting the initial count to 1. We then begin the serial at 9600, which is the serial comes from sampling, reference voltage is 5, text size 1, so on and so forth. And then we go into the loop, which is where we do our fundamental processing. So we've got min, max values. We then create an I counter. We then declaring the real value to be set to the value read divided by 4 minus 256 for the samples. And we set the imaginary to 0, so there's no cross confusion. And just some simple value min, max ratio stuff here. Then pass all that down to the fixFFT, which does the fast Fourier transform, takes the signals and separates it into the frequency bins, where we then display that in this section here, where we have I equals 1, and between 64, I plus plus, and then the data, which is the data displayed, is equal to the real value across the access data here. And then just at the very bottom here, we have really where we print our title. And that's how the code fundamentally works.